Morning friends, we are going to see the two mechanisms that is to that particular reactions, right on a Fry's rearrangement of the phenolic ester and a Claisen rearrangement of the allyl alloxyarenes. This Fry's rearrangement of the phenolic ester having the that phenolic ester when the phenolic esters are heated with anhydrous AlCl3 aluminum chloride, they undergo a rearrangement in which the acyl group migrate to the aromatic ring with the formation of phenolic ketone as a main product. What is there? When a phenolic esters are heated with anhydrous AlCl3, they undergo a rearrangement in which the aryl group migrate to the aromatic ring with the formation of orthophenolic ketone as a main product. This is very simple arrangement. What will happen? Phenolic esters are heated with anhydrous AlCl3. They undergoes the rearrangement in which the acyl group migrates to the aromatic ring with the formation of the orthophenolic ketone as a main product. In some cases, it will gives you the para product. If the ortho position is blocked or say reaction is carried out at the low temperature, the acyl group will migrate to the para position, and this rearrangement is known as called as the Fry's rearrangement. Since this is the phenyl acetate is there, that phenyl acetate undergoes a Fry's rearrangement when you are hitting this particular phenyl acetate in presence of the anhydrous AlCl3. This particular acetate group, that COCH3 group, will migrate to the ortho position of this particular aromatic ring, and it will gives you the formation of the orthohydroxy acetophenone. But at low temperature, when you will heat this particular phenyl acetate at the low temperature, it will gives you the para hydroxy acetophenone. The relative ratio of this particularly ortho and para product depends upon the various factors such as the temperature, solvent, catalyst, and the structure of the ester. This Fry's rearrangement is very much useful in the preparation of the aromatic hydroxy ketone. With application, write a note on Fry's rearrangement. At that time, you have to write about the Fry's rearrangement. You have to write this example. Then you have to write the few word about this particular rearrangement, and it is useful in the preparation of the orthohydroxy or say that aromatic hydroxy ketone. That reaction is very simple that we have seen. This ester is there. Why this ester is there? You can see C6H pi OCO CH3. This is nothing but a ester. You know, CH3 COO. This is phenyl ring is there. Add to that. That means phenyl acetate is there, and this phenyl acetate undergoes the rearrangement when we are going to heat this phenyl acetate in presence of the particular anhydrous AlCl3. It will gives you the rearrangement of this particular acetate ion. This acetate ion from this phenyl acetate will migrate towards the ortho position of this particular ring and gives you the formation of the ortho substituted product, that is ortho hydroxy acetophenone. If we are going to do this reaction at the low temperature by using the anhydrous AlCl3, this will gives you the para product. That means acetate ion will migrate towards the para position with respect to this OH. Remember this. Okay. The relative ratio of this ortho and para product depends upon various factors such as temperature, solvent, catalyst, and the structure of the ester. This Fry's rearrangement is generally useful in the preparation of the aromatic hydroxy ketone. Now we have to talk about the Claisen rearrangement of allyloxyarenes. The allyl arene ether on heating at about 200 degrees centigrade undergo the reaction to form the allyl phenol. This intramolecular rearrangement reaction is called as the Claisen rearrangement. It is nothing but the allyl arene ether on heating at about 200 degrees centigrade undergoes the rearrangement reaction to form the allyl phenol. This intramolecular rearrangement reaction is called as Claisen rearrangement. This can be carried out by heating the allyl arene ether alone or in some inert solvent like the diphenyl ether. In this reaction, the allyl group migrates to ortho position to form a orthoallyl phenol. If both the ortho position are occupied, then the migration takes place to the para position to form the para-allyl phenol. Here the example is given. Allyl phenyl ether. Allyl is nothing but you can see the double bonded compound CH2 double bond CH CH2O. This is the ether is there and allyl phenyl ether is there. Okay, we are seeing allyl arene ether. Arene is nothing but the phenyl ring is there. This C allyl group is nothing but the double bonded compound is there. This allyl group means this particularly CH2 CH double bond CH2 group will migrate towards the ortho position when we are going to heat this particular ether and gives you the orthoallyl phenol. If this ortho position are blocked, you can see here this to both ortho position are blocked, then this allyl group will migrate towards the para position. Are you getting this particular point? Here the allyl 2,6-dimethyl phenyl ether is there. Allyl 2,6-dimethyl phenyl ether is there. When we are going to heat at the 200 degree centigrade, it will gives you the formation of this orthoallyl 2,4 that is a that is a para allele. Okay, or say you can say the 4 allele while naming the IUPAC name 4 allele. Okay, 2,6 dimethyl phenol. Okay, this is particularly the product. This reaction does not require any catalyst. This reaction not required any catalyst. Very simple it is again. What we have seen when we are going to heat this particular allyl phenyl ether, okay, or say allyl arene ether at 200 degrees centigrade, it will gives you the formation of the orthoallyl phenol, or if the both the ortho positions are blocked, then it will give you the para-allyl phenol. Okay, that you have to remember. This is the only two possibilities which are there for this particular reaction. Another question is that how are the following compounds prepared using a phenol? Stepnic acid and N-hexyl resorcinol. Stepnic acid will be prepared by resorcinol. You can carry out the nitration of the resorcinol in presence of the acidic condition H2SO4. What will happen? Thrice HNO3 is there, 3 NO2 group will be there, and that 3 NO2 group will goes to the 3 different position and it will give you the 2,4,6 trinitroresorcinol. This 2,4,6 trinitroresorcinol is called as the stepnic acid. Now then N-hexyl resorcinol is there. We have to prepare the N-hexyl resorcinol. Then we will resorcinol is treated with this particular caproic acid. Caproic acid nothing but the CH3 CH2 4 times COH. In presence of the zinc chloride, it will gives you the formation of the that is the N-hexyl resorcinol. H will replace by this group CO, CH3, CH4, that is a ester. and this ester on further rearrangement will gives you that what will happen, this particular that ion will migrate towards the para position. Then further using the zinc amalgam and presence of the concentrated HCl, this particular CO will reduce to the CH2, CH2 4 times CH3. Here CH3 is missing, you have to write the CH3 also. C double bond O, okay, CH2 4 times CH3 is there, and this will be nothing but the N-hexyl. See, because why the hexyl is there? 6 carbon should be there. This 4 and 5 6. N-hexyl resorcinol. Okay. Now here how you can form the ester. Ester will be formed by treating the phenol with the acid chloride. It will give you the H will replace by the COR bond. Okay. Then phenol when acetic anhydride, it is also gives you the ester. That is a, you can either heat with the acid chloride or say acetic anhydride, it will give you the formation of the ester, phenolic ester. It is called, we can call it as a phenyl acetate. What is the ortho oscillation? How oscillation of phenol is carried out? Here we have seen oscillation. These reactions for the oscillations is there. Then how will you convert benzene into resorcinol, naphthalene into alpha beta naphthol, phenol into orthopara hydroxy acetophenone, cumene into phenol, phenol into orthoallyl phenol, beta naphthol into nerolene, and 2-butyl benzene into 2-butanone. Benzene into resorcinol will be converted by using the twice H2SO4 at the 90 degrees centigrade. It will give the benzene M disulfonic acid, and that will on further hydrolysis with the basic hydrolysis or say fusing with the NaOH, it will gives you the sodium salt of the resorcinol, and which on further hydrolysis with the dilute H2SO4 by using the acidification with the H2SO4, it will gives you the resorcinol. Naphthalene into this beta naphthol and alpha naphthol, that we have already seen preparation reaction. Same reaction is over here. Then phenyl acetate into orthopara para hydroxy acetophenone, that is again we have seen Fry's rearrangement. Then cumene into the phenol, that is again we have seen, this is the preparation reaction. Phenol into orthoallyl phenol, that again we have seen. Beta naphthol into nerolene, that not we have seen. Beta naphthol you have to take, okay. After the rearrangement, bond will, there will be the bond that we can see the electron rearrangement will be there. Here the H will come and double bond will come outside, along with there will be the CH3OH in presence of the H2SO4. This OH3 group will come here and it will gives you the formation of this particular, here bond should be there, okay. Dilute H2SO4. After this rearrangement, this OCH3 group will come there, beta naphthol methyl ether, and this beta naphthol methyl ether is called as the nerolene, okay. This you have to remember. And 2-butyl benzene, 2-butyl benzene into 2-butanone, 2-butyl benzene into 2-butanone. Here you can take this 2-butyl benzene. Cobalt naphthalate is the catalyst at 150 degree centigrade. It will gives you the formation of here COOH, and in presence of the dilute H2SO4, this particular group will left and it will gives you the phenol along with the 2-butanone, okay. OH group will come here after the rearrangement, and this 2-butanone will come outside. This is very simple reaction, please go through it. If you are not getting any reaction, you can ask, okay. We'll stop here. Thank you.